Howdy again, it's Mr. Pete, your interweb shop teacher. I hope you watched that video a few weeks ago where I purchased this used Craftsman drill press, and the reason I bought it was because it had slower speeds and it had a Morse taper spindle and a few things like that. So in today's video, and a 1-horse motor, we'll see if it is, I want to drill some larger holes. So I got like a 3/4 and a 1-inch, and I'm going to drill it into some prepared stock here. It's about 3/8 thick steel. I'm going to see if it stalls out or if it is capable of drilling large holes, because that's really what I wanted it for. At 250 RPM, which is its lowest speed, that's a pretty good speed for big bits. Now there'll be extra credit at the end of the video where I talk just a little bit about speeds and so on in regards to drill size. But there is a chart up here telling you what size or what speed to run your drills depending on the size and the material that you're cutting. So you can always look at that chart. It is a pretty good chart, I'll have to admit, for a Taiwanesium drill. I just coined that word. Just in case you have not watched the other video, this is a Craftsman 30-year-old drill with a 5/8 chuck. And the speed range 250 to 3100, and I have it set again at 250, and it is 1 horsepower, although it really looks like a cheesy little motor and is not capacitor start, so we'll see if it's up to the job. Using large drill bits can be a little tricky and dangerous, so notice that I have it double clamped, and also the bar is up against the columns. Should it grab, the spinning would cause the work to hit the column. So that's a good way to work with long work, that it can't come around and strike you or get pulled up. A lot of things can happen. It's always good to have pilot holes, so I pre-drilled the pilot holes because I'm going to have to remove this chuck now and put the taper shank bit into the spindle. So I'll do that next. Also notice that I'm using wood so I don't drill into the table, because the actual hole in the drill press table is only 1 inch or maybe even a little smaller. So a bit like this is more than likely going to hit if there's any misalignment at all. So this is the better route to go, I suppose. It might be safer to unplug the drill when you do something like this. Again, there's a number 2 Morse taper spindle here. Thousands, probably hundreds of thousands of this model drill press were produced and sold under many names over many years, but several people commented that, oh, I didn't realize mine had the taper spindle. So here's how you remove the chuck or whatever you got in there. You have to have a drift. Remember that on a drift, they're rounded on one side and flat here. So the rounded part goes up like that. And let's see, now this thing's in the way. And catch your chuck or your drill so it doesn't fall. Tap it, and this is just a wedge is all it is. I had to drop the table another inch or 2 in order to be able to fit the drill in. Wipe your drill shanks, your taper, and when you put it in there, you will feel the tang. This is the tang, not a breakfast string. Like that, twist it till you feel it come into place, and then tap it with a lead, or it also works very good to use a lead hammer or a piece of wood or something like that, and then just push down real hard to seat that taper shank. Okay, is anybody taking bets on whether or not this is going to work? Will it stall? Is it capable or not? Will the drill fall out of the spindle? Let's see. "250 RPM. Not bad at all. Now, I was able to stall it, but I really thought that I would be able to as well with that little motor. But I think the motor stalled rather than the belts slipping. I wasn't even actually able to determine that. But that was one size larger than a quarter or 3/4 with a 1/4-inch pilot, as I said. So that was rather admirable. Sometimes you need to work up to it, perhaps a quarter, half, and then the final size. But this is pretty tough steel. It's just like a cold rolled plate or something. It's a drop off, and it's just not free machining at all. But this is the first time in my life that I had a taper shank drill press in my shop. Now, normally when I drill larger holes, I have to use the Bridgeport, but this is pretty good. All right, I'm going to clean up this mess off camera, and then I'm going to switch to a 1-inch bit and see what happens. And this was a fairly sharp drill. However, it was not a brand new drill by any means. Let me just repeat, make sure you got your safety glasses on, and my clamping method here worked very well. Do not think that you could just hold something like this freehand. You will get injured. I almost can guarantee that. I also guarantee that this 1-inch bit is going to stall the machine, but of course that depends on how hard I'm feeding. But yet you have to put a little muscle in it in order to drill thicker steel. There we go. Stop for just a minute. It is the belt that's slipping, and it's the front belt toward the front of the machine, and it's slipping, of course, on the smaller pulley up there. Maybe I'll get a shot of that later on. Naturally, it's not going to slip on the pulley that has the most wrap. I'm going to attempt to tighten the belts a little more, although I don't think it'll do any good at all. Be right back. Okay, I tightened up the drill. But I'm going to tell you now that probably the correct way to do this would be to drill a 1/2-inch hole in there and then finish off with this. It would reduce the strain on the machine, but let's try this again, see if I can force it through by babying it. Okay, I have sped up the footage there just a little bit, but it took 2 or 3 minutes to drill that hole. I am reaching back and touching the motor. The motor is not warm, it is not hot. All the slippage was in the belts, and I'm going to feel the belts. They're warm but not hot. I was going to drill using this 1 1/8 Silver and Deming in the chuck, but I'm not going to do that. I think we all get the point here. Let me take that off. It actually did a nice job of drilling both of those holes. This really is tough steel, I'm not kidding you, so I'm not making excuses for this Taiwanesium, but I'm semi-satisfied. I really knew just by experience that something would slip. I just knew that, because even on heavier drill presses like I had at school, a big delta and a big closing, you could make them slip by feeding too fast or having too dull of a drill. A little behind the scenes footage there. I do have 75 pounds of iron on that little wobbly base and a wedge. When I tightened the belt off camera, I had loosened up the two screws here, one on the other side, and I had extra leverage from this wrench here. And this is the adjustment for belt tension, as I had falsely told you, but a couple viewers gave me a tip on that. Now I want to show you something else about the Morse taper spindle here before we quit. What I'm telling you now is fairly important, and one of the reasons that some people might not have known about the Morse taper spindle is, now I'm going to turn the machine on just momentarily and watch in the tang slot. So right there I'm in the position where I can use my drift. The drift will go right in. More or less, yeah, right there. But depending on where the machine stops, like you just saw, it might stop in that position, and of course you're going to say, where do I put the drift? So you will have to either turn the machine on, but I prefer to just rotate the spindle a little bit, which I'm attempting to do right now. Okay, this is what the belt system looks like. There are 3 pulleys, and I am on the lowest speed. And if you look over here, that's the lowest speed, 250 RPM, and I'm on the lowest groove on this pulley, the lowest groove here, and the highest groove on the other set of pulleys. And looking at the speed chart here, you can see that for steel and medium carbon, which is what we're using, and we get down into the larger bits, and they only show a 9/16. So they're probably not even recommending bits as large as what I just showed you. And at that, for a 9/16, they're telling you to run it at 250. This is the 1-inch drill bit that I use. You can see it's pretty good. It's pretty sharp. Not new, but not chipped or incorrectly ground. Okay, I hope you liked this little demonstration on drilling large holes. If you did, leave a comment, give me a thumbs up and all of that stuff. And for those of you that want to learn just a little bit more, meet me in Studio B directly, and we'll talk just a little bit about spindle speeds and drilling speeds and all of that stuff. So, this is Mr. Pete saying so long for now. Okay, I'm back where it's warm, and this is the extra credit, and this is not meant to be a punishment, although it may seem like a punishment. Now, there are hundreds of reference books and tables in the back of books and Machinery's Handbook, but these are 3 of my favorites here. The Engineer's Black Book has all that information in there. This is a great book. This is a wonderful little book. I've had this for a long time, but the print is so terribly small that I struggle with it, but it's excellent. But here's one that I've had for a while, and I really like it. It's by Cleveland. It's spiral bound, and they're thick pages, not very many pages, you know, about 10 or 12 pages here, but let's take a look through this. And first, let's determine what cutting speed we should use for steel, mild steel, as opposed to aluminum and other materials. This is page 13 of the Cleveland book here, and at the top it says drilling speeds and feeds. We're not worried about feeds because that's how rapidly you're feeding down, and that's done by hand. So if you don't have power feeds, that's a little bit hard to determine. So we're just interested in here in the drilling speeds. All right, I've zoomed in here, and all we're interested in here is mild steel. And if you come across here, it says to use anywhere between 80 and 110 feet per minute. Now that's not RPM, it's feet per minute. And that is why, no matter what book you look at, it's going to give you similar figures. I have always said 100 feet per minute for mild steel. I'm now on page 6. And this chart says table of cutting speeds for fractional size drill bits. I've zoomed in just a little bit and I put a black paper here because we are interested here in a 1-inch drill bit. So we'll come across here until we come to the column here that says 100 feet per minute. And then down to the black line, and it calls for 382 RPM. So I could have run that about 100 RPM faster on that Taiwanesian machine, but it's always better to err a little bit on the lower side, not the higher side. You notice that when I did that drilling in the shop, there were no sparks flying or any other crazy things happening because you want to get the speed a little bit slower. It might take longer, but never faster. So you can determine the cutting speed of any size drill by looking at these charts, but later on you will have a lot of this memorized. But there's for letter drills and many other things in this chart. So this is just wonderful. Again, this Cleveland book, I doubt very much if this is available anymore. This is really an old book. Alright, that's the end of the video. Thank you for watching. This is Mr. Pete saying, I'll see you next time.